Like we did for equations, we would like to be able to manipulate the expressions on either side of inequalities. But with equations, the manipulations that we made were pretty intuitive. To see why we do certain things that we do for inequalities, we need to think a little bit about what happens on the number line when we manipulate them. So I'm going to state the property, I'm going to talk a little bit about why, and then I'm going to show an example of using it. The first property of inequality we're going to talk about talks about what happens when we add a number to both sides of the inequality. For any real number a, we can add it to both sides of an inequality without changing the order. So, I've written the rule separately for each of our inequality symbols. It applies to each of our inequality symbols. Put a little bit more colloquially, we can add the same number to both sides of an inequality without changing the order. To think about why, well, let's look at a number line. And let's imagine that we take this number line and we add 2 to every number. So -4 plus 2 is -2. -3 plus 2 is -1. -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. And 4 plus 2 is 6. Notice, this number line is shifted over a little bit, but it's still in the right order. This is why we can add a number to both sides of an inequality without changing the order. Adding a number to both sides just shifts the number line to the left or to the right. Okay, let's see a quick example of this. Let's say that we have an inequality that tells us that x plus 4 is less than 5. We might decide to add -2 to both sides of this inequality, and we would get x plus 4 plus -2 is less than 5 plus -2. So x plus 2 is less than 3. That's all there is to applying the additive property of inequality. The procedure is just like for equality, except we keep writing the same symbol that we started with.